I am R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we are going to see the topic single stub matching for the course transmission lines and antennas. So, in the diagram, we have a matching network. We know the purpose of matching networks of a transmission line. So, when a high frequency line is terminated in its characteristic impedance, it is operated as a smooth line. So, under such conditions, what happens is there will be no reflections, maximum power delivered to the load, and we get increased efficiency. But in practice, the loads such as antennas do not provide the resistance equal to R0, the characteristic resistance of a transmission line. So, what we have to do is, it is necessary to add some of the impedance matching networks between the line and also the load. So, one method of getting impedance matching is to use open or short circuited stub. So, a stub is nothing but a line of suitable length connected in parallel with the transmission line at a distance from the load. So, because of parallel connection of the stub, it is convenient to work with the impedances in the Smith chart. So, there are two types of stub matching. One is single stub matching and another one is double stub matching. In single stub matching, a stub is connected in parallel to the transmission line at a fixed distance from the load side. But in double stub matching, a type of matching where two stubs are shunted to main transmission line on some fixed distances. So, in this video, we will discuss about single stub matching, and its principle is the input impedance at any point on a transmission line is given by Zs equal to R0 plus or minus Jx. The input impedance is given by Ys equal to G0 plus or minus Jb. So, the inverse of input impedance is the input admittance. As we see, because of paralleling the stub, it is always convenient to work with admittances. So, we have converted the impedance value into admittance value. So, then this short circuited stub of plus or minus Jb is connected at that point across the transmission line. So, the total admittance is given by Ys equal to G0 plus or minus Jb plus or minus Jb minus or plus Jb. So, this plus or minus Jb minus or plus Jb get cancelled, we get only G0 value. So, when Ys equal to G0, Zs equal to R0. So, if Zs equal to R0, we get the impedance matching at the transmission line. So, thus the line from the source to the point is then terminated in R0. It acts as a smooth line. So, design parameters, there are two parameters in single stub matching. One is the point of stub connection, that is from the load side where the stub is connected across the transmission line. So, this is known as this point of stub connection. And next one is how much length the stub should have, that is the length of the stub. So, these are the two important design parameters of a single stub matching. So, consider a diagram. So, here the input impedance is Z0 and load impedance is R0. So, here a stub of length L is shunted across the transmission line from the load to the point where the stub is connected, as the distance is S1 and the point is denoted as A. And from the point of stub connection to the V minimum point, first V minimum point from the load is taken as V minimum, and the distance between V minimum to the point A is taken as S2, and the distance is D. So, length of the stub is given by the formula lambda by 2 pi tan inverse of root of 1 minus mod k squared by 2 mod k, or this formula can also given in terms of S standing wave ratio. It is L is equal to lambda by 2 pi tan inverse of root S by S minus 1. So, here lambda is the wavelength of the line and K is the reflection coefficient of the transmission line. K is equal to ZR minus Z0 by ZR plus Z0, and S is the standing wave ratio. So this is the length of the stub to be placed d meters towards the load from a point at which a first V minimum existed before the attachment of the stub. And this d, the distance, is calculated from the formula plus or minus cos inverse of s minus 1 by s plus 1 into lambda by 4 divided by the pi value. So at this distance, the stub should be connected from either direction from a V minimum nearest to the load. So here a problem is given: a 75 ohm lossless transmission line to be matched to a 100 minus j 80 ohms load with a shorted stub. Calculate the distance from the load, stub length, and necessary stub admittance. So to find the solution, we have to find out the d value, distance value. It is 0.0941. It is obtained from 0.4338 minus 0.3393, and this stub value, shorter stub value, y stub is equal to minus j 0.128 moles. So in the diagram, the problem is solved and it is given. So y value, the normalized admittance, is obtained from inverse of normalized impedance, that is diametrically opposite point of normalized impedance. So it is 0.48 plus j 0.26. So now the load impedance ZL is 25 minus j 250 ohms. J 50 ohms is connected to 50 ohm transmission line. So here we have to insert a shunt element to eliminate reflections towards load from the sending end of the line. So we have to get D value, and its frequency is 100 megahertz. So now the advantages of short circuited stub over open circuited stub is: the length of the short circuited stub can be easily changed, but it is not easy in an open circuit. Because of the shorting plate at the end, mechanical rigidity of a shorted circuit stub is better when compared to open circuited stub. The open circuited stubs do not behave like a true open circuit, and they also possess fabrication problem. So these are the advantages of short circuited stub over open circuited stub. Because of this reason, in single stub matching, always short circuited stubs are preferred. Assessment: purpose of impedance matching network to avoid reflections. We know the difference between single and double stub matching. Only one stub is used. In double stub there are two stubs are used, and the specific conditions to achieve matched condition are the input characteristic impedance must be matched at the receiving load impedance. Short circuited stub are preferred open circuited stub. In stub matching we have seen already. Thank you.